Good morning, students. This is Mr. Botinsky here, and we are looking through the extra practice on page 207 of your Big Ideas Math Student Journal. Before we get into the problem today, we're just going to look again at our polynomials and naming it, and then we'll get into the adding and subtracting of those. So just some quick review here. A polynomial is a monomial or sum of monomials. So each monomial is called a term of the polynomial. A polynomial with two terms is a binomial, and a polynomial with three terms is a trinomial. So monomial is just a single term. So remember that. The degree of a polynomial is the greatest degree of each of its terms. So a polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. So that's one of those things that you might want to highlight. So decrease from left to right. All right, or underline when you're looking at your notes there. When you write a polynomial in standard form, the coefficient of the first term is called the leading coefficient. So right there we have an example. We have the leading coefficient variable, and then its degree, and then as we see this, the very last term is called the constant term. So in our extra practice, we are going to do the evens. So 2 through 20, I believe, evens. So it says find the degree of the monomial. So in number 2, we have just the variable w. It has nothing else with it. So we can think when we see a variable without anything written up there, it has a 1 up there. And that's what the exponent would be, but we don't write it because we understand that it's to the first degree if nothing's written. And we just talking about that, we understand. Find the degree of the monomial. It's going to be 1, or you could say first degree. Okay. The degree of 1 or its first degree. For number 2, we have negative 2abc. Now, when we have multiple variables here. So each one of these variables will have a 1 after it. So it's a is to the first power, b is to the first power, c is to the first power. So we actually have to add up each of those powers of each of those variables. So it is going to be 3. Okay, so it has, the total of all of the powers, or a third degree polynomial. So number 6, we have 4r squared s cubed t. So here again, that t would have 1 after it. We have to add together each of those powers. So 2 plus 3 plus 1. If you need to type that in real quick, you can just use that calculator on Desnos and get 6. And we could say 6th degree. So it's a 6th degree polynomial. For number 8, we have 2 over 3, or 2/3. So we don't see a variable. And if we don't see a variable and we just have numbers, we know that this is a constant, so it's going to be 0. Okay, or 0th degree, we can say constant. Okay. So pause the video right there. If you want to do 1, 3, 5, and 7 on your own, you can check your answers here in just a little bit. There are your answers to the odd numbers. We're going on to page 208. On page 208, we are going to be looking at 10 and 12 here. So write the polynomial in standard form. Identify the degree, the leading and the leading coefficient of the polynomial, and then classify the polynomial by the number of terms. So we have a lot of things that it is asked. First, we need to write it in standard form, and then we need to say what is its degree, what is its leading coefficient, and then we're classifying it. Like that's a lot of items there. So in number 10, we have the square root of 5y. So if we only have one term, a monomial, it is already written in standard form. So that is one convenient thing. So it is now written in standard form right there. Identify the degree. So the degree is 1. The leading coefficient, I'm just going to put LC. The leading coefficient is this number that's being multiplied by our variable. That leading coefficient is going to be the square root of 5. And then classify it. Well, this is to the first degree. When something is to the first degree, it is linear. Okay, it's a linear and there's only one term, so it's a monomial. So a linear monomial. And for number 12. So in number 12, first thing we need to do is write it in standard form. So we're looking for the highest degree. We have f to the second, a negative 2f, and then an f to the fourth. 4 is the highest, so we're going to write f to the fourth first. 2 is the next biggest, so plus f squared, or f to the second power, and then minus 2f. Our degree, so the degree of the polynomial is the degree of the highest term. So it is beneficial to write it in standard form first before we start trying to figure out its degree to some extent and its leading coefficient for sure, because then we just looking at the first term inside of there. We're just looking at this one. right there. We're just looking at that one to find its degree and its leading coefficient. So degree, our degree of 4 or fourth degree. So our leading coefficient is, if there's nothing written, remember, there's a 1 out in front of that. So its leading coefficient is 1. And we have fourth degree. When something is to the fourth degree, it is called a quartic. So we can say it's a quartic. And there's 1, 2, 3 terms. So that would be a quartic trinomial. Okay, again, a quartic trinomial. We are going to go back over to the other side, to page 207 real quick and write a few things down. So thinking about our different degrees, we have, if our degree, okay, is 0, we have a constant. If our degree is 1, it is linear. 2, we have a quadratic. 3, we have a cubic. 4, quartic. And yes, I realize quadratic and quartic are very similar. The way to think of it is quart, like quarter. We have 4 quarters and a dollar. That's how I remember quarter. Quartic is 4. And then 5, quintic. And after that, we just say we have a 6th degree and 7th degree. But these lower degree polynomials, we actually have specific names for them. But we can say that 0, 1, 2, 3. Okay, so you can use that to be able to name your polynomials in number 9 and 11 on your own. So check your back with me. So pause the video right here and try number 9 and 11 on your own. Here we have the answers to number 9 and 11. For number 9, 3x squared plus x plus 5. Our degree is 2, leading coefficient of 3, and it is a quadratic trinomial. For number 11, 6x to the 8th plus 3x to the 5th, the degree of 8, the leading coefficient of 6. We can say that's an 8th degree binomial. We're moving on to look at 14 and 16. And it says find the sum. So, and then we'll also be doing 18 and 20 here. So when adding our polynomials, we can rewrite this and group our terms that are similar. So we both have a to the first power there, and then our constants are there. So we're able to rewrite these as negative 3a. We're adding 7a, minus 2 plus 5. a negative 3a plus 7a. That's really like 7 minus 3a, so we're going to have a positive 4a. And negative 2 plus 5 is going to be plus 3. That right there is our answer. It's already in standard form. So highest degree to lowest degree. So again, that is our answer for a plus 3. In number 16, let's look at this one. We have t squared plus 3t to the third power minus 3, all plus 2t squared plus 7t minus 2t to the third power. So let's see, we have a t squared there, a t squared there, a t cubed there, and a t cubed here. A constant term. And in hindsight, I should have done just the t next. And then we have just a t to the first power there. So we are going to combine those from highest degree to lowest degree. So we're doing this strategically. So 3t cubed minus 2t cubed. And we're going to look at our t squareds. So we have plus t squared, and then plus 2t squared. Okay. And next we are going to use our plus 7t. And last, minus 3. Now we need to combine those like terms, and we've conveniently done that and organized it. So it's highest degree to lowest. So 3 minus 2 of our t cubes, we're going to have 1 t cubed, or just t cubed. T squared plus 2t squared. Well, that's one of those plus 2 more is going to be a total of 3 t squareds. And then our 7t and our minus 3. That's it. We added our two polynomials. We're going to go ahead and box our answer. So number 18. This time we're subtracting. And so it's important when you're subtracting. That subtraction sign is going to make everything in the second polynomial opposite. So it's beneficial to rewrite this. So we have negative 5h minus 2. And so we had a positive 7h, but when we subtract it, that's going to be minus 7h. We had a positive 6. It's going to become minus 6. Okay. Now we can go through and look at this. We have our negative 5h and a negative 7h. Then we have our constants, negative 2 and negative 6. So we're able to rearrange this. So minus 5h minus 7h. So negative 5, oh, we'll get to that, sorry. I'm going to rewrite this. Negative 2, negative 6. So this minus 5h minus 7h, that's a total of negative 12h. Minus negative 2 minus another 6 is going to be a negative 8. And that's our answer. Highest degree to lowest degree, negative 12h minus 8. For number 20. Again, it's beneficial to rewrite this and distribute that negative out in front of that second polynomial. So we're going to rewrite this. K squared plus 6k cubed minus 4. So that was a positive 5. It's going to be minus 5k cubed plus 7k minus 3k squared. So the opposite of each of those. So minus 5k cubed minus 7k. And we're subtracting this negative 3k squared. So that's like adding 3k squared. Now we can go through and look for our similar terms. So highest degree I noticed was the cubed. So we have 6k cubed and negative 5. So 6k cubed minus 5k cubed. And sometimes it's beneficial to just look and work that all together and do that down the page. So you'll notice that I'm being very deliberate about this. So then I have plus k squared and then plus 3k squared. Then I have a minus 7k. There's no other, just first power of k. And then I have the constant negative 4. So I can write those. So continuing working down that page, 6 of those minus 5 of those, so that's going to just give me 1k squared, so I can, or k cubed, sorry about that. So k cubed. And then I have k squared plus 3k squared for a total of 4k squareds. And we can't do anything with the 7k or the constant of negative 4. So we have written this in standard form, which is that decreasing order or decreasing degree. Sometimes we call the degree order as well. If you want to see the answers, you can continue watching to see the answers to 13 through 19. Otherwise, thanks for watching and have a great rest of your day. If you stayed with us, you can check your answers to 13, 15, 17, and 19. Few things there to note. In 15, you notice that the x squared and the negative x squared, they zeroed each other out. Okay, so that's beneficial to note. Thank you again and have a great day.